Example 1, analyzing the motion of a particle. The position of a particle is given by the equation S, which is equal to f of t, which is equal to t cubed minus 6t squared plus 9t, where t is measured in seconds and s is in meters. In part A, we want to find the velocity at time t. In order to find the velocity function is the derivative of the position function. So if we want to find the velocity function, then we're going to take the derivative of that function. Well, the derivative of t cubed is going to be 3t squared. The derivative of minus 6t squared is going to give us minus 12t. And the derivative of 9t is going to be 9. So therefore, this is the velocity function. Okay, so now in part B, it's asking us what is the velocity after 2 seconds and after 4 seconds. So the velocity after 2 seconds means the instantaneous velocity when t is equal to 2. So that means we want to find v of when t is equal to 2, and then we're going to plug it into that formula. So it's going to be 3 times 2 squared minus 12 times 2 plus 9. And so that equals negative 3 meters per second. Okay, and then we want to figure out what is the velocity after 4 seconds. Well, that means we're going to find v of 4. So that's equal to 3 times 4 squared minus 12 times 4 plus 9, and that's going to equal 9 meters per second. Okay, now in part C it says, when is the particle at rest? Okay, the particle is at rest when the velocity function is equal to 0. So what is the velocity function? We found that velocity function, and that means that we're looking for when v of t is equal to 0. So the velocity function, which is 3t squared minus 12t plus 9 is equal to 0. And now we're going to solve for t. So we can factor out a 3, and what's left is t squared minus 4t plus 3, which is equal to 0. If we divide both sides by 3, then what we have left is t squared minus 4t plus 3 is equal to 0. And so now if we factor this trinomial, we have the value of 3 here and then negative 4. So what two numbers can we multiply to get positive 3? Then when we add, we get negative 4. We have negative 1 and negative 3. So when we factor this, we get t minus 1 times t minus 3, which is equal to 0. And now let's set both of them equal to 0. So t minus 1 is equal to 0, or t minus 3 is equal to 0. So therefore t is equal to positive 1, or t is equal to positive 3. So when is the particle at rest? Well, we can say that the particle is at rest after 1 second and after 3 seconds. And part D states, when is the particle moving forward? That is, in the positive direction. So if it's the positive direction, that means that we're looking at this function when the value of v of t is greater than 0. So if we take a look at what we found in part 2, those gave us the critical points. So if we were looking at using the number line, Okay, and we know that here is 0. We know that we have a value of 1 here, and then we have a value of 3. And so then we have these regions. So here's 1, here's 2, and then here's 3. Okay, so we know that if we pick the value in region number 1, and let's say we pick a value that's less than 1, so t is going to be less than 1, and so we can pick a value where t is equal to 0. Let's plug it into our function. So we have 3 times t minus 1 times t minus 3. We want to see if it's greater than 0. So this is 3 times 0 minus 1, 0 minus 3. So that's 3 times 3, which is 9, which is greater than 0. So we know it's true here. Okay, and then if we take a look at region number 2, you want to find out, okay, what happens when t is equal to 2. So if we plug that in, 3 times 2 minus 1 times 2 minus 3. So that's 3 times 1 times negative 1, which is negative 3, and that's false. So we know it's false for region 2. And if we look at region 3, let's pick a value for region 3 when t is equal to 4. So we have 3 times 4 minus 1 times 4 minus 3. So this also gives us 9, which is greater than 0. So therefore it is true here in region 3. So what does that tell us? Well, what that tells us is that this inequality is true when both factors are positive or when both factors are negative. Thus, the particle moves in a positive direction in the time intervals for when t is less than 1 and when t is greater than 3. So it moves backward in the negative direction for when t is in between 1 and 3. Meaning that's when this is the false interval. Now what we want to do is we want to be able to draw a diagram to represent the motion of the particle. Okay, so in order to draw a diagram to represent the motion of the particle, what we're going to do is we want to find out, okay, using the original position function, okay, which is s of t, which up here is t cubed minus 6t squared plus 9t. So t cubed minus 6t squared plus 9t. Okay, so what happens when t is equal to 0? What is the position function? So if we let t is equal to 0 and we plug it in, we get 0 cubed minus 6 times 0 squared plus 9 times 0, which is equal to 0. So we know the position is going to be equal to 0. Okay, now what happens when we get to t is equal to 1? So when t is equal to 1, we're going to plug it into the position function. So we have 1 cubed minus 6 times 1 squared plus 9 times 1. And that's going to give us 4. So here, when t is equal to 1, then we know that the position function is 4. So when we start in this position function, we're moving towards the value of 4. So it's going in this direction. Okay, now what happens when t is equal to 2? So if we plug in 2, that's 2 cubed minus 6 times 2 squared plus 9 times 2. And so when t is equal to 2, we can see that the output is going to be 2. So what that means is we're going to have to start going back in this direction. And so here is where s is equal to 2. And so at this point here, when t is equal to 2, we start going back in this direction. Okay, now let's go ahead and find out what happens at 3. So if we plug in 3 cubed minus 6 times 3 squared plus 9 times 3, well, that's going to give us 0. So that means it's going to now start heading back towards 0. So when we see that t is equal to 3, the position is back at 0. Okay, and so what happens when t is equal to 4? Well, when t is equal to 4, we have 4 cubed minus 6 times 4 squared plus 9 times 4, and that gives us 4. So now we can see that we start heading back to this direction. So when t is equal to 4, we know that the value of s is going to equal 4. And let's see what happens at t is equal to 5. So if we put in 5 cubed minus 6 times 5 squared plus 9 times 5, well, that gives us 20. So that means it continues in this direction for when we get t is equal to 5, the position is at 20. Okay, now what we want to do is we want to find the total distance traveled by the particle during the first 5 seconds. Okay, so because of what we learned in parts D and E, we need to calculate the distances traveled during the time intervals between 0, 1, 1, 3, and 3, 5 separately, because that's where it changed direction. So we can see here between 0 and then 1, okay, that interval, then it changes direction between then, it goes from 1 and then to 3 when t is equal to 3. And then we're going to go from t is equal to 3 and then to 5. Okay, so what we want to do is we want to be able to then determine what is the total distance that's traveled. So we're using the position function f of t, which is equal to that t cubed minus 6t squared plus 9t. Okay, so what we want to do is we want to find out what is the distance traveled for when t was equal to 0 to when t is equal to 1. Okay, so that means we want to find out what is the distance of f1 minus f of 0. Okay, well, we found that up here. We found out that when we inputted 1, we got a value of 4. So that means we have the absolute value of 4 minus, when we plugged in 0, we got 0. So therefore, the absolute value of 4 minus 0 is going to equal 4. Okay, and then we want to find the next position going from t is equal to 1 to when t is equal to 3. So we want to find the distance there. So we want to find the absolute value of f of 3 minus f of 1. Well, again, what do we know up here? We know when we inputted the value of 3, we got 0. Minus when we put in the value of 1, we got 4. So the absolute value of negative 4 is going to give us 4. And then we change position again at 3. And we wanted to determine, okay, according to the question, what is the total distance traveled to when t is equal to 5? So that means we want to find f of 5 minus f of 3. And so at t is equal to 5, we know that we got 20. So f of 5 was 20, and f of 3 was 0. So the absolute value of 20 minus 0 is 20. So now we just need to add these up to find the total distance. So 4 plus 4 plus 20 is equal to 28 meters. So therefore, that represents the total distance traveled by the particle during the first 5 seconds. Okay, now in part G, it says we want to be able to find the acceleration at time t and after 4 seconds. Well, we know that the velocity function, which is a derivative of the position function, was 3t squared minus 12t plus 9. So now we want to find the acceleration function. Remember, the acceleration function is the derivative of the velocity function. So the derivative of 3t squared is going to give us 6t, minus the derivative of 12t is minus 12, and the derivative of 9 is 0. So now we know what the acceleration is. Now we want to find out what happens when t is equal to 4. So we're going to plug it into the acceleration formula. So a of 4 is going to equal 6 times 4 minus 12, which then equals 12 meters per second squared. So therefore, there is our acceleration function and the acceleration after 4 seconds. Okay, so now what we want to do is we want to be able to graph the position function, the velocity, and acceleration functions for when t is in between 0 and 5. So let's go ahead and do that. We're going to graph the position function first, okay, and we're going to use the variable x. So the position function was x cubed minus 6x squared plus 9x. And then the velocity function would then be 3x squared minus 12x plus 9. And then the acceleration function is 6x minus 12. Okay, so they want us to graph where t is in between 0 and 5. So we want to make sure that our x values is going to at least go between 0 and 5. So we're going to go from -1 and then to positive, let's say 6, so we can see what that function looks like. And then we'll just make our y-axis just so that we can see it. We're going to go from -12 to, let's say, 25. So we can see this a little bit better. Okay, so here is our graph. Okay, so we know that the position function is the one that's in red. So we're going to call that S of t. That is the position function. The blue graph represents the velocity function, and the green graph represents the acceleration function. So here we can see what's happening with this graph. And now we want to be able to do is we want to answer the following questions. So when is the particle speeding up? And then when is it slowing down? So we're going to take a look at the graph. Okay, so first thing is the particle speeds up when the velocity is positive and increasing. When the velocity and acceleration are both positive, and also when the velocity is negative and decreasing, where the velocity and acceleration are both negative. So in other words, the particle speeds up when the velocity and acceleration have the same sign. So the particle is pushed in the same direction it is moving. So from the graph above, we see that this happens when t is in between 1 and 2. So if you take a look between 1 and 2, we can see that the velocity graph is negative. It's below the x-axis. And you can also see that it's also for the green, which is the acceleration function, is also below the x-axis. And that means they both have the same sign. And if you look at when t is greater than 3, so here when t is greater than 3, we can see that this is positive, which is above the x-axis. And we can also see that the acceleration graph is also above the x-axis. So it's the same sign here. So we can see here that the velocity and acceleration have positive signs. And over here, we can see that the velocity and acceleration have negative signs. So when they have the same signs, that means the particle is speeding up. Okay, now the particle slows down when the velocity and acceleration have opposite signs. That is, when t is in between 0 and 1. So let's take a look here. So in between 0 and 1, let's take a look at the velocity function. Well, the velocity function here in between 0 and 1 is positive. And then over here, the velocity, the acceleration function is negative. So we know it's slowing down there. Okay, and then what about in between 2 and 3? Well, if we take a look at 2 and 3, we can see that the acceleration function is positive, and we can see here that the velocity function is negative. So it's opposite signs there. So again, wherever they're opposite signs, the particle is going to slow down. So we can see what this looks like here by summarizing. So it slows down here, speeds up, slows down, and then speeds up according to this graph.